So I'll just be introducing Dr. Schlein, who is like one of the authors of the book that we'll be centering in our discussion today. So again, Dr. Schlein is a family practitioner and MBA degree holder with more than 3 decades in clinical and management experience. She graduated from the University of Maryland School of Medicine and completed her residency training in Los Angeles, and then where she later went on to practice family medicine, teach clinical medicine at UCLA, and lead various clinical research projects. She and her husband Joel later established a national consulting firm focused on helping healthcare clients build management teams, and she has been involved as a leader in various healthcare organizations as well. In addition to her leadership and clinical careers, Dr. Schlein has authored several award-winning medical fiction and nonfiction books, including Lessons Learned, stories from women physician leaders, and more recently, Lessons Learned, stories from women leaders in STEM. So both books feature several women scientists affiliated with the University of Maryland and will be centered in our conversation today. So I'll pass it on to Dr. Schlein to introduce our other panelists.
Thank you. Let me see if I can share screen, and I'll start with a little PowerPoint presentation. Can you see it? Everybody?
Yes, we can.
So I want to thank you, first of all, for inviting us to speak to you today. It's been a long time since I graduated from the University of Maryland School of Medicine. I was a 1972 graduate. My husband did both his undergrad and medical school at the University of Maryland, but we still have, as long as it's been, we still have great memories of our experiences there. So now let me just tell you a little bit about how I came to write a book about women leaders in STEM. In 2022, the American Association for Physician Leadership published a book that I did for them titled Lessons Learned, Stories from Women Physician Leaders. This was actually a third iteration of a project that I'd started 26 years before, when I was a member of the organization and found that there were very few women physicians who were leaders in the organization, and for that matter, very few women who were leaders in healthcare in general. So the genesis for that book and for that version, the 2022 version of that book, were these statistics about women practicing medicine. So in 1970, there were only about 8% of women practicing physicians. Today in 2023, they're about 36%, which is certainly a good increase. Women are about 50% or more of most U.S. medical schools. And I don't have the recent statistics in terms of your class, but I think that Maryland is one of the few schools that has as many as 60% of the medical school class is female. So despite these numbers, which as I say are getting better, only 16% of the top leadership roles in any area of the healthcare system have been held by women physicians. Now, to write Lessons Learned, Stories from Women Physician Leaders, I found 33 women physicians who defied these odds to attain some level of leadership within healthcare, and I asked them to share their personal stories. So several of the women are from the University of Maryland, they're physician leaders there, including Dr. Kathleen Nuzel, who is professor of vaccinology. She was instrumental in helping to develop the COVID vaccine, and Dr. Donna Parker, who is Associate Dean for Undergraduate Medical Education. Now, after reading that book, my PhD friends asked me to consider writing a similar book about women PhDs in STEM. And while they said that they had experienced many of the same issues as women in medicine, they felt that there were additional challenges that needed to be exposed rather. So in researching the situation for women STEM leaders, I found that these statistics. As an overview, more women earn PhDs today. In 1970, only about 11% of American women had completed 4 years or more of college. 50 years later, U.S. women are the majority of college grads, we're the majority of master's level programs, and in 2020, for the 12th straight year, women earn the majority of PhDs. The downside is that women earn less PhDs than men in STEM. Now, in terms of the workforce, women make up 48% of the workforce, but they only hold about 29% of positions in STEM. And for minority women, Black, Indigenous, Hispanic, and Latina make up less than 5% of the STEM workforce. The gender gap is especially wide in the fastest growing and more lucrative jobs of the future, like technology, computer science, and engineering. In 2021, only about 17% of engineers and 25% of computer workers were women. So since I focused both books on leadership, in terms of leadership, like the situation in medicine, men now occupy more leadership positions in STEM in both academic and non-academic organizations. So based on these and other issues that I deal with in the overview chapter of the book, I began making phone calls to women STEM scientists and to a person everyone felt that profiling women STEM scientists who defied these odds was important and very timely. The book profiles 29 STEM scientists and additionally, two women who are the editors of Science Magazine wrote the foreword, and they are also PhDs and discussed their career paths as well. 6 of these amazing women are all affiliated with the University of Maryland. Rona Hertzano, who's an MD PhD, she's a professor of head and neck surgery, affiliate member in the Institute of Genome Sciences, and now senior investigation and chief of neurology branch, the National Institute for Deafness and Other Communications Disorders at NIH. Unfortunately, couldn't attend tonight because of previous travel commitment. And Dr. Claire Fraser, who's professor of medicine and the founding director of the Institute for Genome Sciences at the University of Maryland School of Medicine, just called me before to say that she couldn't be here. She is, in addition to being an amazing scientist, she's also a competitive ballroom dancer and has had to have knee surgery. So she said that her rehab has been exhausting. And this was really past her bedtime. So tonight you'll hear from 4 of these amazing women tonight who are all affiliated with the University of Maryland. Now, people ask, well, why did you write this book? Well, the goal was to document how the exceptions to this situation, that is women scientists who become leaders in STEM, negotiate these barriers and challenges that they have to face. Some were the first in their families to pursue an advanced degree. Some have reached the pinnacle of their careers, achieving recognition for their research, including major scientific awards. Some are academics, while others have chosen industry or government work. Some are married, most have children. All have dealt with balancing the professional and personal lives. Now, I intentionally chose a diverse group for this project in terms of STEM discipline, ethnicity, where they live and work, as well as where they were along their career journeys. Some of the contributors to the book are better known as they've moved into very senior leadership roles like Rita Colwell, Claire Fraser, and Estelle Russick-Cohn. But this book also profiles a number of younger women STEM scientists who are upcoming leaders who need to be known, like Margaret Dayhoff Brannigan and Aishwarya Iyer. So my hope is that young readers will find these stories so inspiring that they'll consider STEM careers. And those like you who are already majoring in STEM fields as undergrads or are enrolled in medical school or STEM PhD programs will aim to become leaders within their disciplines. Now, since we're talking to a University of Maryland group, I hope that all of you are aware of the university's Meyerhoff Scholars Program at UMBC. Aishwarya Iyer, who's one of our speakers tonight, was a graduate of the program. And that program is now the nation's leading producer of minority bachelor degree recipients who go on to complete PhDs in STEM and MDs, and often both MDs and PhDs, as Aishwarya has done. So without further ado, let's hear from our panelists. Each has agreed to talk for about 10 minutes, but since we only have 4, maybe they can, if they want to speak a little bit longer, that would be okay. We'll have plenty of time for questions afterwards. So I'm going to start with Rita. I'm going to unshare here, and you can focus on Rita Colwell. Let me just tell you about Rita for a minute. There isn't time enough to tell you all of Rita Colwell's accomplishments. She holds degrees in bacteriology, genetics, and studies infectious diseases. Well known for her cholera research. She's the founder and chair of Cosmos ID, a bioinformatics company. She was the 11th director and first female director of the National Science Foundation. She served on the board of directors of Echo Health Alliance since 2012. She's currently the president of the Rosalind Franklin Society. In 1972, Rita accepted a tenured professorship at the University of Maryland, where she remains a professor, as well as an appointment at the Johns Hopkins Bloomberg School of Public Health. At College Park, she is a distinguished university professor in the Institute for Advanced Computer Studies, which is part of the university's College of Computer, Mathematical, and Natural Sciences. And I know I've left out a lot, Rita, but you can fill in, please. Thank you. I think you're maybe on mute. No, I think you're on mute. Rita? Can we unmute Rita?
Oh, my goodness. After 4 years of being on Zoom, one would think you would remember to unmute. Anyway, I'm delighted to be here, and I was just saying hi to Miriam and Estelle, with whom I have a long-term friendship. And Margaret, I'm surprised that it was your grandmother that I worked with very briefly. I'm delighted to have a chance to talk with you all. Um, I, I guess I should say that I really did start out to go to medical school. I applied to 4 medical schools, got accepted by all 4. This was in 1956, when less than 2% of women were in medical school. So that was even lower numbers. And I guess the fact that I was accepted at all 4, in fact, when I interviewed at Boston University, the only thing they asked me was, why didn't I apply to Harvard? I said, I didn't think I could get in, but I guess I could have. In any case, I went to Purdue University. I went there instead of going to Radcliffe because, first of all, I would have had to commute from Beverly Cove, Massachusetts, where I was born and grew up and went to high school. And secondly, the scholarship to Purdue paid for everything, whereas the one to Radcliffe just paid for half the tuition, which wasn't a whole lot in those days, but I think it was $2,000. Now it's something like $50,000. But in any case, at Purdue, I encountered some interesting roadblocks, one of which is as follows. I did accept Yale Medical School, and I was on my way to Yale when I went on a blind date in March of my senior year on this very handsome, newly returned from the military graduate student. We were married 2 months later, and we were married for 62 very, very happy years. So I went to the department chairman and asked for a fellowship, because I figured rather than have Jack lose a year that he had put in graduate studies by us going off somewhere else right away, I decided we should stay, and I would get a master's, he'd get a master's, and then we'd go on somewhere else. Of course, I didn't realize at the time that if you got a master's degree and left, they assumed that you had either flunked your prelims or hadn't done very well, which certainly wasn't the case. In any case, I went to the department chairman and said, I'd like, please, could I have a fellowship? I know some are available. And he very bluntly said, we don't waste fellowships on women. All you'll do is you get married, you're married, you'll have kids, and then we'll lose you. So that was the end of that. I went to my undergraduate advisor. Now, these are the old days when you couldn't even take a course unless you had properly registered with your advisor your list of courses that you were going to take that semester. So my advisor knew that I was an A student. So I went to him in tears and told him the story. And he said, well, he said, their loss is my gain. He said, I just got a grant and I need a research assistant. How would you like to work for me? And I said, fine. He was a geneticist. And so that launched a really fortuitous point in my career, because I had to take Drosophila genetics because that's what he worked in. But I also had to take tomato genetics, chicken genetics, neurospora genetics, microbial genetics, human genetics. This was perfect because at the time, this was when genetics was just catapulting into the forefront. So I really kind of moved along with genetics then from the very beginning, so to speak. Watson and Crick had uncovered the helix structure, having stolen the data from Rosalind Franklin, but we won't talk about that, to determine the structure of DNA, maybe 4 or 5 years earlier. In any case, I did go on, go on in graduate studies. Jack decided that the University of Washington was the place for him to do physics. I applied to the University of Washington and was accepted. However, I got a second letter saying that if you're going to be at the University of Washington Medical School, you have to have lived in Washington State, Idaho, Oregon, or British Columbia, and have paid taxes to prove that you were a resident. Otherwise, you'll have to spend a year living in Washington. And they said, however, we have an alternative. will give you a research assistantship in the microbiology department, or at that time it was the bacteriology department. So I did that, accepted, and made the mistake when I arrived at the University of Washington to mention what my undergraduate advisor at Purdue had recommended, and that was to look up Herschel Roman, who was a very well-known member of the National Academy of Sciences, Drosophila geneticist. So I arrived in the microbiology department, and the first thing they did to us new graduate students was to have us meet with a graduate advisor. So I met with Howard Douglas and mentioned to him when he asked me, what would you like to do? And I said, well, I was advised to talk to Dr. Herschel Roman. Well, you'd think that the look on his face that I had hit him or something. It turned out he hated Herschel Roman. That was not the thing to say on your first introductory meeting with your advisor at the University of Washington. In any case, I went ahead anyway and met Herschel Roman and spent a year with him, but it turned out he didn't like women students. He had one woman in his lab who was his technician. She had been there for 20 years. So in the end, I was pretty discouraged, but I met and heard about this new Scottish professor starting an entirely new program in marine microbiology. At that time, way back in the late 50s, there were probably 5 marine microbiologists in the entire world, and there was no new program. So John Liston, a Scotsman from Aberdeen and Edinburgh, Scotland, took me on as a technician. And after about half a semester, he said, you shouldn't be a technician. You should be my graduate student. So that's how I ended up doing microbiology of marine systems. And I had gathered so much data that they had a new computer had just been installed, the first computer at the University of Washington, the IBM 650. Now that IBM 650 had less computation power than my current Apple Watch, but it was new, it was great, and I was able to analyze my data, and I wrote the first computer program to identify marine bacteria, the first computer program in the US. And the other program had been written by Peter Sneath in England. So that was what we called numerical taxonomy. Sounds really archaic. Of course, that was the predecessor to what we do now with rapid identification on these high-speed computers. So another story that I can't resist telling is that it came time for our postdocs. And it turned out that my husband, Jack, was offered a postdoc at the National Research Council in Ottawa, Canada. And John Liston, my professor, said, oh, I know Norm Gibbons. He's the head of the biology unit at the National Research Council. He wrote to him, and Norm Gibbons immediately offered me a fellowship. So Jack and I were off to Ottawa, Canada. However, I got another second letter. And the letter this time said, because of nepotism rules in those days, husbands and wives cannot each have a fellowship. So it was going to be one or the other, and obviously it was going to be Jack. But my professor, John Liston, said, and I quote, there's more than one way to skin a cat. He said, we will apply for an NSF grant, which we did. The grant came through. And he said, now I will make you the PI, and then I will talk to the dean, and we will make you a research assistant professor, and we will allow you to go on leave of absence as a research assistant professor with your own money to the Research Council in Ottawa, Canada. So I mention all this because I want those who are listening to realize that when things really look awful, find a way over, under, or around whatever the obstacle, and you'll find that it really serves you well. Now, the best job I ever had was director of the National Science Foundation. I'd been at the University of Maryland by this time. I had gone from the Research Council to Georgetown, where I was offered a job. In those days, I simply met the chairman of the department. It was at that time a new department in what was the new building, which is now being renovated, the Rice Building on the Georgetown campus. But I met George Chapman at a meeting, having been introduced to him at the American Society for Microbiology meeting. And we stood in the lobby, and he said, I understand you're coming to Washington. You need a job. I said, yes. He said, I understand you've already got a grant. I said, yes. I understand you have a lot of publications. I said, yes. He said, well, and you want to teach marine microbiology to the undergraduates and microbiology as well. I said, yes. Fine. He says, you have a job. That was how it was. So the bad news in the old days was that you got treated rather badly, but sometimes because the times were different, you could come out on top. So at Georgetown, my lab got very large. At some point, I think I had about a dozen students. It was a very small building. It was built by teaching professors, not research professors. So the building was beautifully designed, but it had very strange triangular bits to it. Have you ever tried to put a centrifuge in a triangle corner? Very difficult. So I moved to the University of Maryland in 1970, and that was the greatest and best move that I ever made. That's where I met Estelle, and had many other wonderful colleagues and graduate students. But at the University of Maryland, I was pretty bold, and I started the Biotech Institute. First of all, I became the director of the Sea Grant program, which is a marine science program. And then I was asked by the president of the university, John Toll, to consider being vice president for research. And I told him I really didn't want to be because my research was pretty heavy. And I had just been elected president of the American Society for Microbiology. And he said, well, the committee wants to talk to you and you can tell them who they should be really looking for. What should be the criteria so that you can help them select someone. I said, fine, I'll do that. So I went to this meeting of the search committee, came back the next day, and John Toll called me 2 days later, and he said, well, they've just selected you to be vice president for research, vice president of academic affairs, and provost. And I said, well, I can't do this. I've got so much. He said, well, just write it all down. So I wrote 2 pages, single spaced, of what I would need. And I sent it to him. And I thought, well, that's the end of that. And then a few days later, he called and he said, would you mind starting within a month? And so that's the story of how I ended up provost and vice president for academic affairs for the University of Maryland. But I didn't want to be just someone who kind of reviewed things. So I started the Biotech Institute, and that was launched. And then Estelle will know there was a lot of trauma, but it got launched very well. We now have a building in Baltimore on the Inner Harbor. We converted a building that was a warehouse for a department store to a medical facility. We converted, we built a facility in Shady Grove, and so it was very successful. And then one day, as I came into my office, my secretary said, the vice president's on the phone. And I said, oh, the vice president of what? And she said, the United States. She said, you better take the call. I said, okay. So I went into my office and picked up the phone. And at the other end was Al Gore saying, well, Dr. Caldwell, I understand that you might be interested in the National Science Foundation directorship. And I said, yes, sir. Yes, I would. So that's how I became director of NSF. That was the best job I ever had. It's only a 6-year appointment, but it was in charge of all science in the United States. Mathematics, physics, chemistry, geological sciences, biological sciences. It was like falling into a cream pudding of everything I ever wanted. So I was able to spend 6 very happy years doing what I really enjoyed. almost doubling the budget. I increased it about 67%. Wouldn't happen today, not with this crazy Congress. And was able to double the math budget. That made people like Estelle very happy. And started biocomplexity and a very important program, the advance program. This was a program which continues to this day. The 20th anniversary was a couple of years ago. And that was to provide funding predominantly for women. But because of the legal aspects of it, it was open to everybody. But it serves women who have had to drop out because of family, either having children or having to care for someone in the family, or for women who needed funding for their research. And the awards were at that time $500,000 over a 3-year period. Now I think it's more like $1 million or maybe 2 million. This was 22 years ago. So I was very pleased. Did a study a couple of years ago and determined that at least 9,000 women faculty, professors, were established in universities around the country as a result of that program. So these are some of the things that I have been doing over the last few years. And I think my time is up. So thank you. Glad to take questions when we come to the Q&A. Thank you.
Thank you so much. So I'm going to ask Estelle to speak next, but let me just tell you a little bit about her. Dr. Estelle Russick-Cohen is a biostatistician from 1978 to 2004. She was on the faculty of the University of Maryland, College Park, where she taught and eventually led a small biometrics group collaborating with scientists all across the agriculture and life sciences. She was tenured in the College of Agriculture. After retiring, she went to the Food and Drug Administration, serving as a team leader in the Center for Medical Devices, as a deputy and then director for the Division of Biostatistics in the Center for Biologics, and then retired again in 2016. She came back part-time to the Center for Drugs to work on policy and to help with rare disease submissions. She now says she dabbles in consulting, but says working for the Gates Foundation, reviewing projects in international public health is her favorite professional activity. She still serves on editorial boards. She's a fellow of the American Statistical Association. Estelle, it's yours.
Thanks very much. Some of my background actually overlaps with Rita Caldwell, curiously enough. I'm a first generation person to go to college. My brother did, but my parents were not. They came to the US just before I was born. And my mom finished 5th grade. My dad maybe finished 10th or 11th grade, and then the war broke out, so they didn't have an opportunity. But one of the things I think is important, even though you go in STEM and you're going advanced degrees, you need to recognize that people can be intelligent with or without those degrees in hand. And I think that that's very, very important. My parents had no idea as to what I was doing for my degree, but that didn't mean they didn't encourage me or didn't think it was great stuff. It was kind of neat, but I thought I would mention that. I'm from New York. I went to an inner city school. Women didn't always do the things I was interested in. That was quite clear back then. I think I was fortunate enough to have good science teachers. I think my math teachers were kind of mixed. Some were outstanding and some were not so outstanding. But sometimes you got the sense that women weren't really supposed to be successful in math. Okay, so then I go to Stony Brook as an undergraduate, and my freshman advisor looks up at me. I'm sure he didn't know my name. And the first thing he asked me is, "Oh, of course you want to teach high school." And I said, "No." And he goes, "Then what could you do?" Keep in mind, I said I wanted to do some sort of a cross between biology and math. And the math department hadn't heard of bioinformatics yet. It was too early on in that genetic revolution. But I was really incensed because I wasn't convinced he would talk to male students the same way he talked to me. Anyways, I found my niche over in the bio department while finishing a double major. I had an undergraduate advisor who did something in a very esoteric field called numerical taxonomy. In fact, Rita knew my undergraduate advisor, Jim Rolfe, and they were very encouraging because biology is not particularly quantitative, and having somebody female who liked the quantitative side of biology, that was great. So I always felt like I fit in, and I consider myself very lucky. But I also remember my undergraduate advisor telling me when I went to grad school that I shouldn't mention a certain other faculty member's name to somebody in grad school because they didn't get along. So one of the things you'll discover in academia, no matter where you are, is they love trashing each other. I mean, it does happen on occasion, and you got to learn to let it rub off, because they're not always trashing you because you're female. They're trashing you because they don't like your research or they find some other reason. And you're just going to have to live with it in an academic life. That's really what you pursue. Anyways, I was lucky because I had a chance to do research and stuff that undergraduates didn't do research in. And computers were a little bit better than when Rita was in college, but they were still pretty archaic. My smartphone, smartphone does more than the stupid little computer I worked with in high school and certainly in college. But then I took a year off. I went and I worked as a programmer after college. And I did finish that double major, by the way, in math and bio. And I needed to earn money because I wanted to go to grad school and I didn't have enough money for airfare. And so curiously enough, I picked the University of Washington in Seattle. And I went because they had an outstanding program in biomathematics and biostatistics. And it was broad enough that I didn't have to narrow down the particular niche I wanted till I got there, because I really hadn't decided that much. I wanted a chance to explore a few things. And eventually I wound up doing biostatistics in grad school. But the first day I was in the department, I met my advisor, who was head of the program. He became my advisor. He introduced me to all the female faculty by their first name. But the male faculty were Dr. Fisher, Dr. this, Dr. that. I should have been upset because he knew fully well what he was doing. But it was the first time I actually met women with a PhD. So I was really shocked, you know. So the environment was so different than today. I think today there are so many more opportunities for women to perceive things, to pursue topics that they're interested in, etc., relative to what I had. But my department was actually reasonably good for women. I mean, when the male faculty thought it was cool to joke about models and they would show you a striptease person on the screen, they got nailed by the female faculty. We didn't, and female students, we just didn't put up with it. And so the climate changed, women were successful. And even though I was told by some faculty that women can't do stat or women can't do mathematics, and they go, oh, but we didn't mean you. You know, it just, there were some outstanding female students that have gone on to do great things after they got out of grad school. And, but the environment has to be there. So when you go to a department, you need to feel like you're part of the group and that you can be successful. And I hope programs have changed. There were only about 5 programs in biostat in the country when I started grad school, but there must be about 40 or 50 out there now. And there's many, many more opportunities. And in contrast to pure statistics, I think we heard some of the statistics early on about women in STEM. Biostatistics in particular seems to attract a lot of women, okay? And now we not only have statistics, that is a big growth area, data science is imploded. And I think there's great opportunities for women, and you don't even have to be a genius in the most theoretical statistics. My niece is so funny. My brother says she can't add, but yeah, she graduated Phi Beta Kappa from Wisconsin with a degree in statistics and poli-sci as an undergraduate. And but she can't do arithmetic. So my brother was absolutely shocked that she did that. But then I went on after Seattle. I wanted to work in basic science, primarily motivated by the experience I had in college, but it was unusual. I didn't go to a school of public health, and I wound up at Maryland, okay? University of Maryland, College Park. And I was there for 26 years. But I got really lucky. I was really naive. I was lousy at negotiating. And even though several of the senior faculty members, all male, because I was the only female in my department, were actually pretty good about helping me along, the department chair held the budget and he had no interest in supporting anything I did. And it was horrible. So who salvaged my career in a lot of ways? Well, you're meeting her. You just met her, Rita Cole, because we met at the end of my first year at Maryland. and we did a lot of collaborative research together. But in addition to that, one of the things that hurt my life as a statistician is it's not just the attitude in the department. There were things like computing resources weren't there, software wasn't there. You know, you don't want to reinvent things that existed in other places, because I used to stand online to use a computer package that was archaic and arcane compared to what I had in grad school. You need the resources in order to be successful. And Rita Cole helped me get the resources. Some of you may or may not know what statistics packages are like, but we brought SAS to the College Park campus, and it was amazing. A campus that size did not have a state-of-the-art package for the basic sciences, and we brought it there. Mostly because Rita had a budget to work with, and I was willing to help and give her a little advice. But my comment is mentoring was so important. And if no matter where you are, it's fantastic to have a mentor. And the mentor could be male, it could be female, it doesn't matter. But it has to be somebody who helps you navigate. And there's a lot of politics to navigating resources and being successful and things like that. And so there's an element of luck and there's an element of skill. And the whole time, even though I was somewhat isolated in a very small unit of biostatistics, I made it my business to be active in my profession. That's the other advice I would give. I was very active in the American Statistical Association. Why was that good? When I got stuck in a stat problem, I sent emails to friends. Have you ever seen something like that? And they would point me to references. And sometimes I found the references and I could really move forward. You need those connections. It's an opportunity for leadership to stay active in professional organizations. And you can be isolated. Everybody's isolated academically because departments do not want to hire two people with identical research interests. So you're always going to be at least a little isolated in an academic environment if that's the way you are. But it's really great if you go to meetings, you might find people with similar interests and you overlap and you get connected, and it's an opportunity for a different kind of leadership. So I happen to think that that's a really important thing that you ought to do. Statistics in Maryland is extremely political. The University of Maryland, Baltimore County has a very nice department that does statistics, in case you're interested, because I've actually spoken up there. Maryland is very compartmentalized, is the way I would describe it. There are very good statisticians, but the politics of trying to create a department were a disaster. I think I chaired one of the last programs, and they finally said that they weren't going to do it. And they created an interdisciplinary program to sort of keep things at bay. I didn't really care per se because I was in a small unit, but the math department thought they were the only ones who knew how to teach statistics. The business school thought they were the only ones who needed to teach their kind of statistics, etc. So there's politics everywhere is my point. And I got tired of it. And I finally went to FDA. I went into a unit that had 40 PhD statisticians. But I was the only one who felt comfortable walking into a lab. It doesn't mean you want me in the lab, but at least I knew what the equipment looked like. I knew how to heat up my coffee in a Bunsen burner, things like that. I mean, I could talk the language, and I could sometimes read articles that say, this is what we're worried about, and I could translate it for the statisticians. And that put me in a somewhat unique role at FDA, and it was really great. And I stayed there for a while. And I have to agree with the chat. Rita's career is amazing. And I was fortunate enough to meet her on that rise. But at FDA, I managed to succeed. I worked in every pre-market review division of the Medical Device Center at FDA by the time I'd been there for 2 years. And I was helping junior people find their way around, find solutions to problems they had, etc. And then 5 years after I came, I moved over to the Center for Biologics, where I was the division director for a division of biostatistics. They reviewed every vaccine that's ever approved. So even though I was long gone, everybody asked me about the COVID vaccine. So I had to listen to all the hearings, and people asked me whether they were rushing, whether they did a bad job or whatever, and stuff. It was great to have that kind of exposure, to that kind of experience. So even at the Gates Foundation now, I'm working on vaccines. I work on diagnostics. In fact, I'm the only statistician in the group I'm in, which is about 50 people, that really has extensive diagnostic experience. And so I love the contribution to public health. I mean, that's my passion. Really got me started on it. I haven't even talked about the junkets we took together. I've been to Ecuador, I've been to Bangladesh, I've been to Jamaica, and I've been to a bunch of other places, compliments of Rita Colwell and some of the really, really interesting, important problems in international public health. And so to me, that was phenomenal. So I had fun along the way. And on my personal life, I think it's relevant. I met my husband a couple of days before I got my 10-year letter from Maryland. So I told him he was my lucky charm. And I have two daughters, one of whom was a Banneker Key Scholar at College Park, and then did a PhD in immunology at Johns Hopkins. And now she's doing medical writing because she decided she didn't want to publish or perish career in the lab. And I said, fine, that's what she makes her happy. And she seems to be very happy doing it. And my other daughter is press secretary for Senator Warner from Virginia, not press secretary, communications director for Senator Warner from Virginia. She did internships the whole time she was at Georgetown. So she told me she didn't like science and she worried whether that would bother me at all. And the answer is no. You can be okay even if you're not a STEM person. But I'm very proud of my kids. And I think that that's really important. And I'm hoping today it's easier because I had friends who were afraid of saying they were pregnant when they were going up for tenure. And having a family to me is important. And it's great that you can find ways of juggling it. And Rita and I have something else in common. We both have two wonderful daughters each. So having that ability to balance things doesn't necessarily mean you sacrifice a personal life. And I think that's important. And I think I've said enough. I'll let the next person talk.
Thank you so much. That was great. So Margaret, I think you're next. Let me just tell you a little bit about Margaret. Dr. Dayhoff Brannigan is a primary reviewer and regulatory project manager in the Office of Vaccine Research and Review at the Center for Biologic Evaluation and Research at the FDA. She graduated from the University of Maryland with a BS in biochemistry and from Johns Hopkins School of Public Health with a PhD in biochemistry and molecular biology. Her thesis work focused on understanding nutrient sensing pathways using yeast as a model organism. After her doctoral work, she took a role as a senior fellow and project manager at the National Center for Health Research, a nonprofit organization focused on health policy and patient safety. She's been in her current role as a primary reviewer and regulatory project manager at the FDA for 7 years. In this role, she manages the review of a broad range of files, including vaccines, allergenic projects, and live biotherapeutic products from early phase development to post-licensure. So Margaret, take it away.
Thank you. It's a little bit hard to follow Rita and Estelle because I'm still early phase in my career. But I graduated from the University of Maryland back in 2005, and it was 4 really wonderful years of my life. Unlike others, I'm actually a 3rd generation woman in science in my family. My grandmother, as Rita mentioned, had a PhD in biochemistry. She got her PhD from Columbia in New York, and then they relocated. My grandfather was also a PhD in physics, and they relocated to this area after the war. And then my mom went to the University of Maryland and then on to Georgetown Medical School. So it wasn't really an option for me to go into STEM. It was, presented as this is what you're doing. My grandmother actually passed away right before I was born. So I was named after her, and it has a certain amount of privilege walking into a room having your name be a famous biophysicist. And even in this room, somebody recognized the name and knew to mention it. So it's been a real blessing. But I also haven't encountered the same challenges that other women have because I was raised in a family that said women can do science. Women are great at science and women are brilliant. And you have no limitation by being a woman. You have no limitation from having children. And this is something you can do. And I found faculty mentors that shared the same views. I've worked for a lot of women, and they all had children and they all made their careers work as well. And that's been a great, great resource and a great mentorship for me. So I went from the University of Maryland. I actually was pre-med, like I know a lot of you guys are. I took the MCATs. I thought about med school, and I looked at the application, and the first question is, why do you want to go to med school? And I didn't really know. So I thought that maybe I needed to take a little time to figure out exactly what I did want to do. So I worked at Johns Hopkins in a lab run by I was a doctor who ran a research lab, and he much preferred research. And I found that I thought research was a better fit for my personality and for the things that I wanted to do. So I ended up at the School of Public Health at Johns Hopkins, which was a great way to kind of learn the different public health fields and to get excited about some of the public health. But I was still in a really basic science laboratory. My research was basic science genetics. I did tetrad analysis. If you've learned about that in genetics, it's as basic science as you can possibly get. And about halfway through my PhD, I realized that that wasn't really quite the right fit, that I really wanted to be in something a little bit more public health. My skills are a little bit more in management and in regulation. So after graduating, and actually my mentor there recognized that. She felt that she didn't see the passion for research that would help me be successful in an academic research career. But she thought that I was really passionate about other things and that I should find something that was a little bit of a better fit. So I went on to a nonprofit in DC where I did general sort of review of drugs and devices and applications to FDA for whether or not drugs and devices were safe and effective, and advocated for stricter regulations for a lot of medical devices. And she also did a lot of science policy work, and it's a really hard area to be in. Science policy is very difficult. And I worked there during Obama, and I'm sure it's only was only worse for a few years. But I really enjoyed the type of work there, and I transitioned into a patient education program, helping to educate patients who had been injured by medical devices or other drugs, to advocate for safer and more effective clinical trials and things like that for other drugs. So from that experience, I got to know a lot more about what the FDA does, and I took an opportunity. And I know somebody mentioned this, but keep in touch with everyone from grad school, because somebody posted on Facebook that they had a job opening at FDA, and I messaged them and I said, "Oh, what do you do?" So I ended up at FDA, and I'm in the Office of Vaccines, and I've been here for 7 years. So it's been a very interesting 7 years to be in the Office of Vaccines. So I'm a project manager, but I have a science background, and most of the project managers in the Office of Vaccines all have PhDs, or a lot of them are nurses as well, or other clinical background. And we manage a team of physicians, statisticians, and PhDs to manage the review for drugs and drugs. And then we also have a lot of device combination products, because vaccines have a lot of combo products. And it's been really interesting. You're at the cutting edge. You get to see all of these new products coming in and kind of figure out what to do with them. I know we mentioned, obviously I do vaccines, but I also do a lot of live biotherapeutic products, which is a really interesting area of research. It's kind of the hot area for both probiotics and also other microbiome treatments have been a big area over the last 10 years. In terms of advice, I would say that FDA is a really, really wonderful, family-friendly place. I work with a lot of women. A lot of women end up there who want to be able to balance a family. A lot of women physicians who don't want to be in a clinic all the time, who want to be able to have more regular hours. So it's been a really great place. I have 3 young kids. I have an 11-year-old, an 8-year-old, and a 4-year-old. So it's been really great to be able to manage my schedule, and it's a very supportive environment. And even during COVID, I can say some of the people on the biggest projects for COVID all had kids and families, and we're somehow making it all work. So it's been a good place to be. I don't, we can wait till the Q&A. You guys can all ask any questions you have for me.
So last but not least, then, is Ashwara Iyer. Ashwara is a 6-year medical MD PhD candidate. Her PhD candidate is in biochemistry at the University of Maryland School of Medicine. Her thesis work interfaces biophysics, structural biology, biochemistry, and muscle pathophysiology to investigate the molecular pathogenesis of a novel sarcomere gene mutation that results in a progressive clinical myopathy associated with tremor. She wrote this, but outside her academics, she has served as president of her university's student government, as a student advocate, co-created climate change and health curricula within the medical school. She served on the LCME ISA Student Committee, vital for the medical school reaccreditation process, and she served as the inaugural research chair for the National Medical Students Division of the American Medical Women's Association. Prior to her physician scientist training at the medical school, she attended UMBC for her undergraduate studies as a Meyerhoff Scholar and NCAA Division I athlete to earn her BS in biochemistry in 2018. As an undergrad researcher in the Howard Hughes Medical Institute laboratory, she has co-authored papers published in Science and the Journal of Molecular Biology. She's the eldest child of an immigrant family and the first person in her family to pursue an MD or a PhD. So, Ashwara, it's up to you to tell us more.
So I think I have the least amount of experience out of everyone on the panel, so I'm just completely honored and grateful to have this opportunity. So as Dr. Schlein said, so I'm a first generation Indian American, and my dad grew up extremely impoverished in India before he immigrated here. So he really instilled in me the importance of a really strong work ethic and taking every opportunity in front of you. So that being said, my path to science was, and where I am today was, carved out of, my own volition, but also I wouldn't be here without mentors and advocates, like Dr. Caldwell and said, and many of the other panelists said, like, you need mentors and advocates to kind of get to where you are. It takes a village. You can't do it by yourself. And I was extremely shy and introverted. I still am. Talking in front of a group of people would make me tremble. I would have to, when I had a presentation, whether it's in middle school or in undergrad, I would write a script and I'd memorize it and memorize and memorize it before I would present. So I realized at some point that I really needed to change, and in order to achieve my goals, had to deliberately step outside of my comfort zone to grow professionally and personally. My first instance in research came in high school. So, I was an average student. I didn't particularly do as well as most of my classmates. My family didn't know anyone in research or medicine, but I really liked science and math. My grades in English were probably also because my grades in English and other classes were like C's. So I kind of just gravitated towards like the classes that I kind of did better in. I took a molecular biology class in high school, and I was really fortunate where I went to high school. We would actually like learn how to run gel electrophoresis experiments and, pick colonies out of agar plates and like, perform like tiny little techniques that you would do in the wet lab. And so I applied to a ton of internships and I got rejected from all of them. I didn't know anyone at NIH where some of my classmates had family friends. I didn't know anyone in the medical field. So I was really disheartened. I got a random email one day from someone at an Institute for Bioscience and Biotechnology Research, which was kind of right across the road from where I went to high school. And they were like, we somehow found out that you're taking this molecular biology class. I need an intern who can do some of the techniques that you've learned. Do you want to come in for an interview? And I was just like, yes, I want to, I wanted to do research, and I just like, it was one opportunity and I just kind of took it. And that kind of, led to, was one of the pivotal moments that kind of led to where I am today. And so because of the experience, I really got hands-on learning experience. I was just honestly growing up bacterial cells and spinning them down to isolate protein. But it was still such a, interesting experience for me. I really like to work with my hands. That kind of led me to decide like I want to go into more of a research intensive undergraduate journey. So I was fortunate to be accepted into the Meyerhoff Scholarship Program at UMBC and have the opportunity to play Division I tennis, which was very challenging, but really kind of excelled. The idea that success takes sacrifices, when you have to play 15, 20 hours a week on top of doing research. And at that time, I was an engineering major. So figuring out, what's important and also prioritizing yourself sometimes, and saying no to friends when you can't socialize and things of that nature. So during my freshman year at UMBC, so as part of the Meyerhoff program, we are required to apply to at least 17 internships. And I was like, okay, I have some research experience. I was doing better in college than I did in high school and my undergraduate education. Like I hopefully will get an internship. And I got all of them rejected, like every single one. And you'd think that, maybe at least one. So I just then emailed tens and tens of faculty on campus. And out of all of them who said they don't have money or they don't have any positions, I got 2 responses. And one of them was from Dr. Summers, who's a Howard Hughes investigator at UMBC. And I had a wonderful interview. And he was just like, okay, I actually like stopped accepting students for like the past few months, but I'm going to give you a shot. And so I kind of just took that and ran with it. And this is where I learned the value of mentorship. I got exposed to what MD PhD programs were in that lab. My mentor was an MD PhD student. So at the time he started his PhD as when I joined the group. So I was able to see a project from start to finish in the lab. And I switched my major from chemical engineering to biochemistry because my project really opened my eyes to how something on so just to give some insight. So we basically found out how an addition of 1 or 2 nucleotides at the beginning of the HIV-1 genome had the ability to determine the fate of the HIV RNA and ultimately its function. So whether it's going to be packaged into the viral genome as genomic material or be translated to encode viral proteins necessary for, the capsid, the viral particle. So that kind of just opened my eyes to how basic science can be so fundamentally crucial for understanding a clinical disease. And so that's why, I didn't really know anyone or too many people who were doing that kind of work, seeing individuals who have MD PhDs who wanted to do like more biophysics and structural biology. But that was kind of realized what I wanted to do. And so that's how I ended up going into, I then got a pre-MD PhD internship at the University of Minnesota, worked with a physician scientist, was able to see that bench to bedside research. There was a cancer lab, but it was still phenomenal, none of the same. And so I ended up here at Maryland for my MD PhD training. And during all of this, Maryland kind of opened my eyes to, I'm not someone who likes to do just one thing. I kind of like to do a lot of things, and really how one of the, I guess, pieces of advice as, early in my career as I am, is that you don't have to be at the end of whatever didactic end goal or, defined endpoint, like at the end of a degree or anything like that, to make a positive impact on your community. At Maryland, I've been really fortunate to have a supportive environment where I was able to work with faculty, staff, and students to try to do some good in the community. So I was able to get involved in creating medical education, being involved in student government, where, you get to interact with amazing people, regardless of medical students, dental students, law students, to see different issues they're facing and how you can kind of come together to address these issues on a larger level. Be a part of initiatives like starting a food pantry for students to address food insecurity. Like things like that. Like you can start early. It doesn't have to be, after you graduate or after you go to residency, or after your postdoc or anything like that. And then at the same time, I wouldn't be able to do this if I didn't have supportive mentors. So being in this path where I initially didn't know anyone and who had like MD or PhD, I had to quickly learn like networking, who is important, like significant, like from all of these stories, it's very clear, like, and they can really, if you have a good mentor and you have established mentors, they can pick up the phone call, and that phone call can be game changer. And so I know I probably wouldn't be here without Dr. Summers, mentorship and advice. And my mentor right now, she's phenomenal. And the research project that I've created in the lab is not something that anyone has done in the lab before. And I came in saying I wanted to build on things that I've learned in the past, which is RNA structural biology, but now doing something different, but utilizing skills that I have. So doing protein structural biology and learning new techniques beyond the techniques that I've learned before, and working with physicians and physician families, patient families from around the world, to understand a disease that is kind of emerging and understudied. Sorry, I kind of went on and on, but in addition to mentors and advocates, I'll also say peer mentoring is really important throughout this whole process, whether it's in research in the lab. Like I actually just went into a neighboring lab the other day, and I was like, I am interested in doing a specific type of RNA-seq for a project, and I have no background in RNA-seq, but you do RNA-seq. Can I meet with you tomorrow to pick your brain? And she's like, absolutely. So like, just peer mentoring and connections are so important, and building those type of relationships. And then just, be comfortable being uncomfortable. Being outside your comfort zone is the only way to grow. As someone who had a lot of stage fright, being part of like our student government and talking for 2 hours in front of 50 people, and then having meetings like every other day, was not easy. But I now look back and it's like, okay, I could put together my committee meeting today for a presentation tomorrow. It'll be totally fine. So it helps boost your confidence and helps you grow. So identify your strengths and areas of improvement, and kind of work from there.
So thank you all of you for speaking so well. Lauren and Tam, I'm going to turn it over to you for Q&A.
Yeah, so thank you guys so much for sharing your stories. I know it was really wonderful to hear about them, and really impactful for, I think, myself and a lot of the other students here today to hear. So thank you again for that. So at this point in our presentation, we want to open up the floor to our members to see if you have any questions for our panelists here today. So you are welcome to put them in the chat, or you can private message them to me if you want them to be read anonymously. And we also have some other questions prepared. So we'll just give a minute for people to send in messages if they have any. And, oh, yep, if you haven't, you can unmute too and ask your question.
Oh, okay. I was just wondering if we could speak. The first thing I want to say is hello to Rita, and something she didn't mention that she did was she managed to get Newt Gingrich, of all people, to triple the size of the National Science Foundation budget. That is truly a miracle.
I wouldn't call him my best buddy, but I was grateful.
Of all the people to do that, if you could do that, again, it's a miracle. And then I would just like to say that I've been active in getting women into STEM for at least 15 years now. And it happened because I started out as an energy attorney, and I found myself translating between the engineers and the lawyers and the politicians. And the next thing I know is I'm on Capitol Hill explaining the science to the politicians and the political situation to the scientists. And then I have many ties to the University of Maryland. I was on campus just last week because I'm on the board of a charitable organization that donates funds to PhD students in the sciences. And we were given a tour of the new IREAP building and the new centrifugal mirror fusion experiment office and lab. And so that was really, really fascinating. And we also listened to the people we donated money to give presentations about the research. And I also just recently took a group of women from the Association for Women in Science to do a Capitol Hill Day. and explain what it's like to be a woman scientist, the challenges and the obstacles, and what their concerns were to, for example, the head of the science committee on the House side and certain senators that are extremely involved in getting the CHIPS and Science Act passed. And we were also working very closely with the head of research at the University of Maryland, College Park, and Dr. Pines, of course, also. And so next week, I'm also getting a tour of one of your new science buildings, your new computer science building. So it seems like I'm on campus all the time. And Rita, I would have stopped by to see you, except that I was carpooling. But I also just gave something that's really, really important for you all to think about is entering public service. I just gave a lecture at the NYU to NYU undergraduate women in the sciences, encouraging them to enter public service. If we are concerned about the lack of public trust in science and the reactions of people, during the pandemic to the request to wear masks and get vaccinated, we have to improve the faith of the public in science and the scientific method. And the way to do that is for young scientists to get involved in the process and at all levels. And, it's wonderful if in mid-career, you're you can get named to an important position, but really the way to do this, and as another career option, this is very important too, in addition to medical school and the traditional academic pursuits, is it's very rewarding. You get your ideas in front of the people that can implement your ideas. So consider public service. And I want to thank everyone for speaking because, it's wonderful. The more stories we hear, the better it is.
Great. Okay. Thank you so much. So I think we have a couple of questions. One of the questions is that all of you all mentioned the value of mentorship in your careers and throughout your lives. So do you have any advice about seeking mentorship or where students should be looking and how they should initiate a conversation when looking for guidance from a more experienced professional in the field?
I don't mind saying something. Our professional societies have mentorship programs too. So some of it could be local, if you're fortunate enough to have them. But I know several of the statistics organizations, both the Biometric Society and the various sections of the American Statistical Association, offer mentorship programs within, where senior people come along and help junior people pick career paths, or at least open them to ideas, courses that might be good to take to help them make decisions about whether they like something or not. That's one option. Sometimes if you're a junior faculty member, you're lucky and a senior faculty member takes you under your wing. And as a grad student, you hope that you get a good advisor. I remember when my daughter went for a PhD, we had long discussions about picking a PhD advisor because they should be a mentor, but they're not always. And so you need to learn to ask the right questions and stuff.
I think, I can add a small tip of a red flag that was a red flag in my career is people whose labs are all women or all men. I found it to be a red flag, and I got hired into a lab technician position with a boss who only hired women. And he Googled them before hiring them and only hired specific women who looked a specific way or, had things on their resume that were a red flag. And he was a little bit creepy, and he liked to hire women because he liked to push them around and he liked to make them work unreasonable hours. He liked to ask them to do inappropriate things like come to his house to write papers. And while he did not cross any lines, it was still an uncomfortable situation to be in. So he was not a great person to work for, and definitely a red flag for me when picking a thesis lab. I was deciding between two labs, and one was a man who only had women in his lab, and the other was a woman who had women and men in their lab. And I felt a lot more comfortable with her, because I didn't quite know what was going on and why somebody chose to only hire women in their lab. And I kind of do think it was a little bit of, sometimes men will want to hire women who they can push around, or ask to, work unreasonable hours or do things that are maybe boss them around in an inappropriate way. So that was sort of a red flag for me and sort of a X factor in picking a mentor for a PhD lab.
Well,
I will say I work for a man now who is perfectly wonderful. But it was just a red flag for me in picking labs and I think the same is true actually for labs where it's all immigrants, because a lot of them are a little more vulnerable, as well to overwork and to working ridiculous hours.
yeah, I think you're making some really good points. I just graduated my 60th PhD and I counted 29 of my PhD students were women. I didn't realize that till I counted. And also it was sort of United Nations. Estelle can attest to that. Students from Europe, Bangladesh, Asia, South America, a mix. I mean, there were American-born students as well. So I think that kind of an environment is very enriching. You learn from people with whom you don't normally meet, and you get to know them and find out that they're just the same warm, kind-hearted people with interesting customs from their backgrounds that you can share. And I do think that's important for growing professionally, being comfortable with people from everywhere around the world. I think that's really important. And selecting a mentor, I think you more or less get selected sometimes by virtue of common interests. And I think that's the key part. It's having genuine common interest in science, and it doesn't hurt to have a similar interest in the kind of hobbies that one has. My husband and I were racing sailors, and so I got to know a whole set of other people who were helpful, interestingly, because they turned out to be some professional scientists, some from Maryland as well. This was out of Annapolis. And so you can find mentors in very interesting places.
Just to quickly add on, so in terms of like mentors for thesis or like labs, definitely talk to students within the lab if possible to gauge the lab environment to see if it's a good fit for you. What's a good fit for you might not be necessarily what's good fit for someone else. And then mentors in general, like outside of research or maybe within research, but not necessarily labs and generally career advice. So generally within academia or even, research in general, like it's a very collaborative environment. So most people are very open to, if you just cold email or, someone saying, I'm really interested about your work or about your career path and I want to talk. For the most part, I would hope, at least for as far as I've seen, the worst thing that they can do is say no. So sometimes you'll get no's, but sometimes you'll get yeses, and the yeses might be worth it.
Also, there are some formal mentor programs like with the American Medical Women's Association. So particularly for pre-med and med students who might, be looking for mentors, that as far as I understand, that they're actually, you can speak to them about actually development, getting assigned a mentor.
Yeah, MWA does have an official mentorship program.
Great. That sounds like there's a lot of different ways to find a mentor or not find a mentor, and yeah, and that there's some programs out there to help us as well. So that was great. Our next question is, are there any challenges that women face in your fields that you feel are not talked about enough, and why do you think they're less talked about?
I'll add one that happens to me in government is they tend to give women the jobs like planning the Christmas party and things like that, the non-promotional additional tasks that take an immense amount of time and effort. And I don't know if other women here have also been tagged with the party planning, if you will, when somebody retires, somebody needs to, coordinate the gift. And there's not a single man in my office that has ever had to participate in such things. But it takes time away from some of the jobs and the committees that you could be working on that increase your promotion potential, essentially. So that's sort of the unspoken women's work, I think, these days, where it's a task that you're given, and if you say no, it looks bad. You look like a woman who's not willing to do whatever at the workplace, but it also doesn't contribute to promotion, and it takes time out of your daily schedule.
It can be subtle too, because
Yeah, it's very
I
subtle.
was the only female in the department, and every search committee, they wanted a woman on the search committee. And in fact, one time I met somebody from the ag economics department, and I got introduced to Nancy, and her first reaction is, no, we've never met. We've never been on the same search committee. Because they always had one on every search committee, and they spread us out. You don't get credit for being on search committees, trust me.
And interviewing people, things like that, it all takes an immense amount of time.
Yeah.
Also, this is a way where mentorship is important. I had a very, very bright student who went to MIT. She was going to take a year off, and I said, no, you're not. I got on the phone, talked to the chair at MIT, and said, I've got a really, really bright student. Anyway, she went to MIT to do her PhD. And she called me when she was finishing her thesis, and she was very upset. She said that her mentor, who was a Nobel laureate, would come back for meetings and would have lots of suggestions for jobs for the guys in the lab, but he never discussed jobs opportunities with her. And so I asked her what job was she really interested in, and she said, well, there's a job at Harvard that I think I would fit. I said, fine, go there, submit your application, and I'll submit a supportive letter. Story short, she's now a full professor at Harvard and has been a full professor for the last decade and is a member of the National Academy of Science. So the moral of the story is that you need to seek out and not just let whatever the happenstance, negative happenstance is, you need to take some action on your own.
Just to add on, I guess, some of my experiences, very subtle ways in how I'm treated differently than my men counterparts. I had to work twice as hard a lot of the times, which a lot of, women have to, just get the same amount of respect and just get treated the same way, and to get more response, like, be, saying that I'm competent enough, even though I know I'm competent at what I do. And, I like to think sometimes that my work ethic speaks for itself. And I just put my head down and I work. I walk fast. I go from point A to point B. But if I'm not smiling all the time, sometimes that comes off as rude, and that I'm, not approachable. Just because I'm busy and, I don't need to smile all the time. But if someone else does that, a man does that, that's not the case, and they're efficient, or, they're assertive. And if I do that, I am aggressive. So that has still yet to, I think, improve, and having a really good support system in your lab environment does a lot to, at this point, like, and, being comfortable with yourself and what you can do, and not letting that get to you is something that I've had to learn, and I'm still learning. So that's still, I don't know how long, or if that ever goes away.
Well, that's very interesting, because as I told you, that half of my students were women, and I noticed very early on that when the women students came into the lab, they would politely ask may I use the balance, or may I use the centrifuge, or whatever. The guys come in the lab and say, get out of the way, it's my time on the centrifuge, or I need this, move on. So there's a very different aggressiveness, not that you should be aggressive, but stand your ground.
Absolutely.
You know, I'll add to that. One of the ways that women often get dinged on their aggressiveness is salary negotiation. And I know my PhD mentor made a point with her female postdocs to not automatically give them raises, like you get a raise each year in a postdoc, because she wanted them to come to her and ask for it to practice that negotiation with someone. And it's, you know, it's in a comfortable place, but she wanted her women postdocs to feel comfortable saying, look, I deserve a raise because I am good at my job. And it is a very hard thing to do, to go in and say, look, I'm good at my job, I deserve it. I have a family to support and I deserve to be paid more. And I think that's still an area where women really struggle compared to men, because we're kind of trained to feel like we don't deserve to be paid more. And obviously there's still a big salary gap. And I think part of it is the fact that we don't come in with that aggressive, assertive action, and that's important to continue to work on, and something that, you know, certainly is a place for women to improve and to feel confident in.
One thing that I, whenever I giving talks, I out to women's groups, my advice is get a posse. Do you know what a posse is? A posse is a circle of friends that you meet with on a regular basis, have coffee or beer or wine or whatever, and talk over the problems that you come up with. And you'll find out that you're not the problem, it's the system. And you'll find out that you're not alone, but other women are having similar problems, as you're learning today from this discussion. So get yourself a posse.
Good advice.
I was going to say it's not just negotiating salary, it's negotiating the resources you need to get your job done. I watch men get labs, and I had trouble fighting for the little bit of computer terminal that I needed to get my job done. And I think that's where a mentor can help. What is reasonable to ask for and not out of line? And then you should be assertive about the things you need to get your job done. And sometimes it's more than just the salary, because then they can justify later, you didn't get this done or that done. As soon as I hired an RA, the number of papers I had just skyrocketed, because I had somebody to take care of the more mundane things that I didn't have to do anymore. So that kind of negotiation is it's part of the package too, I think.
Great. Yeah, those were definitely great answers. So we have just a few minutes left. So I think we'll just end with like a final question, and that's where do you hope your field will be going in the future? Like, what are your goals or hopes for future women who decide to pursue your professions? Just a brief little answer.
Well, I'll start. I'm doing work right now that I really, really am excited about, and that's using satellite sensors to do predictive modeling of pandemics. I've been doing this for 60 years, working on cholera, and we now provide cholera risk prediction for the United Nations for Yemen, Ethiopia. We're working in the Gaza Strip right now, making predictions as to whether or not there will be a cholera outbreak. So I think that satellites are going to be a common public health tool, along with AI and machine learning. So that's where I see public health going.
I guess I'll go next. I'm a statistician, and I will tell you our organization is very much into data science, artificial intelligence, and using those tools. At FDA, because I taught data mining and other types of things at the university, I got to see some of the medical devices that had underlying machine learning or artificial intelligence algorithms underneath, and I reviewed them with an eye towards whether they answer the question, are they safe and effective, if you will, in terms of terminology. I think that stuff is still imploding, they were exploding, and it's going to change the way things are. In fact, computations generally change statistics altogether. It started off very theoretical. Now you can do all these really applied questions where, you know, the total approach to even designing clinical trials has become very computer intensive. So I expect to see more and more of those kinds of things in the future.
So I think one of the most interesting things about being in the Office of Vaccines during the COVID pandemic has been seeing what we were able to accomplish in a really short amount of time, when given almost infinite resources. So I just really, really wish that we are in a political climate that will continue to give infinite resources to solving some of the, some of the biggest diseases. I really would love to see what we could do with things like Alzheimer's if we could actually put forth a lot of effort. I hope in the future there's more funding for research, and maybe we can finally make some headway in some diseases that really have just been sitting.
Well, I'll let Ashwara speak and then I'll say something. Go ahead.
So I mean, again, very early in my career, I'm more on like a very rare disease. That's kind of we're understanding more about, but I would love to see, I'm very interested in the future in targeted therapeutic development. So seeing that structure function relationship all the way to translation on bedside. So having a lot of those pipelines created for these mutations and these rare diseases, because there is not a lot of also funding for rare diseases where there are individuals all over the world and in the country affected, but targeted therapeutics that are made so that they are sustainably made, but also they're accessible to the patients that actually need the medication and cost effective. So that's what I hope for the future.
I would just say that for those of you who are going into medicine and thinking about being clinicians, that you think of yourself as a physician scientist and be open to not just leave medicine, medical school and residency and sort of go into your office and practice, but really keep learning, because there's just so much that we really need to improve, medicine and science in general. So I'm hoping, as you don't have to necessarily get an MD and a PhD, but at least be constantly learning, because it's not enough to just finish school and residency.
Great. Absolutely wonderful. It was so great hearing from all of you, hearing each of your stories. And I just want to thank you so much for spending your evening with us and giving us your time. I know I really enjoyed it, and I'm hoping our members did as well. If you're comfortable, our members might have some follow-up questions. So if you want to leave like a way to contact you in the chat, or you can send it to us afterwards if you're okay with that, we'd love to forward that to our members. And with that, we have our attendance form in the chat for our AMSA members who are here today. And yep, I think that's all we had today. Thank you so much, Dr. Schlein, for getting this group of panelists for us today. We really, really appreciate it, and we just really enjoyed your talk today.
Thank you so much. Thanks all of you for participating. I appreciate it.
Yeah, of course. So I think that's it for our talk. So have a nice evening, and thank you so much for coming.
Thank you. Bye-bye.
Thank you.
Thank you.